All right, we're on the t-test one sample tab, and the question to determine whether or not you use a t-test or a z-test is, do you have a population or a sample? Or more specifically, do you have a population standard deviation or do you not? If you have a population standard deviation, then you can use the z-test. If you do not have the population standard deviation, then you use the t-test. Because population standard deviations are so rare, more often than not, you're going to be seeing the t-test. All right, so here's the scenario. The average number of steps taken by the professor from one building to another is 275. A class counts their steps to see if there is a difference. So the key word in this question is the difference. That's going to be an alternative type statement, so H1. So the professor not equal to the students, and the null professor is equal to the students. All right, for a critical value, we're going to be using the 95% or 0.05. Decision rules, I'm going to be going back over here, copying, pasting here. Now we just need to find our results. So basically, if the p-value is greater than 0.05, we fail to reject the null. If the p-value is less than 0.05, we reject the null. Okay, go to my add-ins, Megastat, hypothesis test, mean versus hypothesized value, clear everything out here. I'm going to be putting in a summary input. Don't forget to highlight the label. It says label mean standard deviation n. My hypothesized mean 275. T-test, alternative not equal, push OK. Now at first blush it says, oh well, 3.05 is definitely bigger than 0.05. Well, e to the negative 12 is saying 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3, 0, 5. You move the decimal points 12 spaces out there, so 11 zeros in front of it. Now that number is definitely smaller than 3.0 or 0.05. Hence the reason why it's in yellow. Again, a fun little feature about Megastat is it will put in yellow statistically significant or things that are below 0.01 significance level. All right. So it looks like our hypothesized value is 275, our mean is 300. Yeah, they look pretty different. So I'm going to be putting in for my results, 0 is definitely less than 0.05. Therefore, we reject H0. And our null is that they are the same, therefore they are different. Analyzing a result, there is a difference between the students and the professor's number of steps taken from one building to the next. Maybe the professor is unusually tall, maybe there's a number of shorter people that may need to take more steps, maybe they took a different route, whatever, we don't know, but that's pretty much the result. Okay, on to the next series. In this case we have 10 instead of 30. Similar situation, I'm changing it up a little bit. Is the professor's the same or more steps than the students? Now the key phrase here is the same and more. So this is going to be a null hypothesis type statement. So the professor is greater than or equal to the students. The alternative, professor is less than the students. Or in other words, the students take more steps for the alternative, the null, the professor takes more steps. All right, critical value, let's change it up. Let's put 99 percentile, 0.01. Similar decision rule over here. Except we are going to be changing this to 0.01. Okay. So if greater than 0.01, we fail to reject. If less than 0.01, we reject the null hypothesis. And let's get our results. So megastat, hypothesis test, mean versus hypothesized value. This time we're going to be putting in the data input. And you don't need to highlight the number, but it is nice to highlight the label. 275 is the same, and in this case, we want less than. Okay. T-test looks good. And we push OK. All right, our p-value is 0.99999. Okay, so we have a hypothesized value of 275, a mean of 350. So it would seem at first blush that they are the same. But what's actually ending up happening is because the standard deviation is so big, we cannot say statistically that one is bigger than the other. So that's why the p-value is so high. So my p-value is 0.9999. 0.99 is definitely greater than 0.01. Therefore, we fail to reject the null. That is to say, the number of steps taken by the professor are the same, or, let's go back up here, greater than the students. And the reason for that, again, is because going back to our output, the standard deviation is so high, they're not, while they may seem pretty high, 75 is the difference between them, but that's a little more than 2 standard deviations away. So therefore, statistically, they're not big enough to be statistically significantly different. Therefore, we failed to reject the null hypothesis. They're pretty much the same, or professor may have bigger, but we're going to say go for the same as each other. They're not statistically that different. Okay, so that is the t-test with one sample.